Welcome back to Shannon's Lumber Industry Update. This is episode 34, and I'm dipping into my inbox here because I've had quite a few questions build up over the last couple of months since I've really done one of these. So today we're going to talk about teak. Does it actually dull your blades? We're going to talk about some moisture concerns and delve a little bit deeper into case hardening. We're going to talk about the colors you find on the ends of the boards, the emerald ash borer, some hornbeam questions, and a really cool process called compression wood. So it's quite a full show. I'm looking forward to it. Let's dive in. First, I do want to say thank you to Kurt and Rob, who both became patrons since the last show. Thank you guys so much for your continued support. The support over there just continues to grow, and it just kind of boggles my mind. So thank you all for being patrons. If you are interested in that, you can go to patreon.com/lumberupdate, and all the details you need to know are right there. So you guys, if you listen to Wood Talk, you probably heard that we have a sawmill. The lumberyard where I work has purchased a wood miser. Now, we're not really going to be getting into the practice of, milling our own lumber from logs. Certainly an organization our size would probably go with something much, much larger than a wood miser. But we do have quite a few custom projects where we are creating either really, really wide laminate floor, or in some instances, we're doing some larger timber type work. And we're just finding that it's more economical to import. Let me back up. A lot of these, while some of them are domestic, a lot of these projects are calling for exotic species of wood. And it's nearly impossible to get large timbers and some exotics. And we've just found that we can do it ourselves. So we got ourselves a wood miser, and we don't have it in its final location yet, but we've been, we set it up in front of a couple of our kilns just to kind of test it out, make sure things are working well. Have one project underway right now involving some Iroko slabs that we have to saw into cants, and then we have to saw some of it into lamellas for flooring. So we've been kind of playing around with that. Frankly, it's been a lot of fun. I've been really interested since we said we were going to go down this road to do this. So it's kind of nice because I talk to a lot of sawmill operators day in and day out. Obviously, I'm good friends with Matt Cremona, and I've seen a lot of band mill operators over the years, but I've never really had the chance to stand there and crank it through myself. So it's been educational. It's been nice to kind of put a lot of the theory into practice. So of updates on that, and certainly if I can talk about some of these projects we're working on, I will delve into those as well. Kind of fun. So let's jump into the main topics today. I've gotten many questions over the years about teak. I have a fair amount of teak showing up on my workbench in my own shop. I do happen to work for the largest importer of teak in North America, so we have a lot of the stuff floating around, and I've actually gotten a lot of experience working with material. And it seems like every time I put a hand plane or a chisel to a board of teak, or I run teak through my power planer, people are like, man, that's really tough on the blades. And oh, you got to sharpen all those blades now because you just ran teak across it. And I call myth on this. I'm not going to deny the fact that teak has a very high content of silica. It's grown in sandier soils, so that sand, the silica, just sucks right up into the fibers. And oftentimes teak will have kind of a glint to it, and you'll find even white stained particles throughout the tree sometimes that have some reflection to them because it's high amounts of silica. And that's one of the things that makes teak a great exterior species, is it's like impregnated with silicone. You might as well just run some caulk over it and you're good to go. In addition to the high extractive level, the high resins and oils in teak, it's just a phenomenal exterior wood, but much of it is because of that silica-rich chemistry. But, while there's no doubt that if you were to run your blades over sand, it's going to cause problems. Why do you think we sharpen our blades on sandpaper? But I think in many instances, the blunting effect of the silica in the teak is ameliorated, if not eliminated, by the high oil content. The waxy nature and sometimes oily nature of the wood acts as a lubricant, and I have not seen any lasting effects. Now, here's the thing. The power tool I have in my shop, the Grizzly planer, is a carbide insert planer. When we plane and do any milling of teak at the lumber yard, we're using carbide blades. We don't use we do have one planer that is straight knife steel blades, but we're pretty much using our carbide planers for this. So it's, carbide's really, really hard. So it's highly possible that the blunting effects that you may see from teak just really don't show up very much with carbide tooling. If you run typical high-speed steel or any other tool steel across them, you may see some more blunting. And no, I do think you do see more blunting, but only at power tool RPMs. When I work teak with hand tools, I'm not sharpening anymore. In fact, I find the wood to be so easy to work. It's one of my favorite woods. It's a shame it's so bloody expensive because it is just an absolute joy to work by hand, to the point where I think it's a wood species that actually works better by hand than it does with power because of the kind of self-lubricating possibilities that all of that oil provides to it. So for those of you who are afraid to work with it because they think you're going to like take one pass with a hand plane and have to sharpen again, or it's going to completely destroy any of your power tools, you might need to pay a little bit more attention when you're dealing with higher RPMs. But, for so many people now with carbide cutter heads in their joiners, carbide cutter heads in their planers, certainly carbide brazed teeth on your table saw, I really don't think it's going to be that big of an issue. If you're going to be afraid to work with teak, be afraid of the price tag, not afraid of the silica. It's a phenomenal species to work with. So I got a question from Dan about storing boards vertically. I've mentioned this in the past, probably in just kind of in an offhanded comment about how if you stand your boards up on end, the free water will actually drain out the bottom. We see this a lot in many foreign sawmills, or I should say many foreign lumber concessions, where the logs are felled and a lot of instances they are sawn into kind of a rougher board out in the bush with something like a Wood-Mizer band mill. Then those boards are stood up on an A-frame so that they are running near vertical, close to vertical, where all the free water can drain out. This reduces the weight dramatically, and it makes it a heck of a lot easier to put it onto a flatbed truck and pull it out dirt roads, often muddy roads, in advance of the rainy season. If you try to haul out a bunch of green lumber that's so much heavier, inevitably your truck is going to get stuck in the mud and you'll never get it out of there. So that initial drying is really just gravity drying. It's removing the free water, not the bound water. The water that's in the cell walls is the bound water. That's the stuff that you've got to let air dry over years or run through a kiln in order to get rid of it. So yes, I absolutely think if you have green wood in your shop, I highly recommend leaning it up against the wall. Come back, depending on how green it is, come back an hour later, come back a day later, and you will see a puddle on the ground below that board. Now, key point, make sure you wipe up that puddle, because if the water stays there, if the board stays sitting in a puddle, there's every possibility that it will actually soak the water back up via capillary action into the wood. No, you want to move that wood and then remove that puddle of water and then allow more water to drain out. And keep mopping up that puddle and putting the board vertical until you stop getting a puddle forming. At that point, your free water has now just gravity drained out of your board, and you would be surprised your moisture content is probably down to 25, maybe even 20%. So much of that, 80% moisture content when a tree is first cut down is just water, and so much of that is free water. So you can take a huge step forward in your drying if you let it gravity drain. Also, if you're going to air dry it from there, well, now that your board we'll go high and say it's down to 25 or 30%, think of the head start you've now given it when you start air drying it. Or if you put it into a kiln, you're going to be a lot better off. Moreover, you're going to avoid a lot of mold problems. With that huge amount of moisture content in those boards, you definitely don't want to be stacking those. Certainly not dead stacked, but you definitely don't even want to be stickering them, because you're going to get water actually dripping in between the boards and causing all kinds of stuff to grow in there, as well as some attraction for the bugs. So gravity draining it will prevent a lot of that sweating and mold that you might get from a board, and it will dramatically speed up your kiln process. In fact, can also help dramatically reduce kiln defects because there's not such a huge amount of moisture that's already in there being removed when it first starts out. So absolutely, I highly recommend this. It's as I said, it's seen in the commercial sector a lot. We just don't see it this far down the supply chain with a lot of the exotics because it's happening overseas. So this brings me to the next question. It's actually a voicemail. This is also from Dan, different Dan, but he's got an interesting kind of a concern about case hardening, and I wanted to talk a little bit more about that. Let's listen to his voicemail first.
I have a question about case hardening. I have a solar kiln / dehumidifier kiln that I built last summer. I have it set up so that the solar part's facing south. I have 2 fans running constantly 24 hours, 7 days a week in a convection type circulation. I've had smoke in there to make sure it worked. So those run nonstop. I haven't had my dehumidifier running in the past 2 months. It gets 120 plus degrees in there during the day. Fully insulated. It's a beautiful thing. But I'm wondering about case hardening. I'm a little bit nervous. I just learned about this year between you guys and Wood Talk and you yourself. So can this case hardening ever change, or once it happens, it's forever? Just concerned because I have some beautiful lumber inside there. I got some beautiful slabs. So yes, shed some more light, please. Will case hardening last forever, or can it eventually equal out? Thank you. Keep up the good work.
Okay, good question. I don't know if you guys can hear that worry in Dan's voice, but yeah, I understand. You've got some nice stuff in there and you worry about it being ruined. Well, let's back up. I know that I've talked about case hardening before, but have I actually really ever defined it? And certainly if you go back a couple of episodes, I talk about the whole tuning fork idea. And there's an image in the show notes about that tuning fork. The idea being you cut a slice of wood out of the center of the board, and then you cut a notch out of that. So you have this like tong looking shape thing. And depending on how the board warps or deforms or not, is whether or not it is ready conditioned, if it's case hardened, or if it's reverse case hardened. So Dan, that's one thing that you might want to do is take some samples from your boards. The thing is, you really want to be taking a sample from deeper inside the board. I'm not saying cut the board in half, but go maybe a foot, preferably 2 in from the end of the board and cut a slice out. That can be a problem. If you want to use every extent of those slabs you've got drying in your kiln, that could be a particular problem. But you may also find a fair amount of in-checking and things that happens just as normal in a kiln, and it might be worthwhile cutting it off and then doing a tuning fork test just to see how your lumber is. The case hardening is when the soft, gooey inside of the Twinkie stays soft and gooey, and the outer foam cake shell of the Twinkie gets dried and hard. So what happens is the outer layers are drying faster than the inner layers. That's going to happen always. But if the temperature gets too high and things dry too fast, that outer layer dries almost completely, and it's trying to shrink, but it can't shrink because the inner layer, that gooey filling center of the Twinkie, is still soft and moist, and it doesn't want to shrink, so it's holding its shape. So what happens is, certainly some cracking can appear around the outer shell, we'll call it. But what really happens more often than not is that outer shell gets stretched. The fibers get stretched apart as it continues to shrink and shrink and shrink around that inner shell. So then much, much later, as the inner core of the board starts to dry and come into equalization with the outer shell, well, that outer shell has already been stretched and deformed. And as the center shrinks away, the outer shell can't handle it and it starts to crack apart. Or in some instances, you start seeing huge amounts of cracking right through the core. There's just too much tension going on there. Oftentimes, the case hardened board is kind of the telltale by looking at the end grain, and you'll see these large checks, but fully contained checks. They're not checks that run from face to face. They stay within the core. Those have opened up during that stretching and then collapse process. That is a product of case hardening that's actually called honeycombing. You also can see some things like cell collapse, which is similar in some respects, but it's also kind of specific to certain species. But the whole idea is the the outer shell gets kind of hardened and stretched, and then the inner shell or the inner core dries away and it kind of separates from the outer shell. And eventually the outer shell just kind of collapses in on itself. And you get these kind of long grooves and channel looking things on the face of a board. The easy answer to Dan's question is no, this is not reversible. But case hardening is not like flipping a light switch. 1 second you're not case hardened, the next second you are case hardened. There are certainly going to be shades of gray here, but the real issue that happens with case hardening is that stretching of the outer shell. You can't really undo the stretching by adding more moisture. Those fibers get stretched to the point where they're not the same as they were before. Think of a piece of plastic like a credit card, and you bend it back and forth several times. You'll see that the plastic starts to become white down the middle as that plastic is stretched and deformed. And then you can flatten that credit card out again, but it's always going to have that white line where the material was stretched. Same type of thing is happening with the wood. So once the case hardening sets in, you're starting to see that stretching of those outer fibers, and that causes real problems later on. There's no more moisture you can inject into the wood to fix it. Now, there is a difference between case hardening and reverse case hardening. And if you haven't listened to my episode about dehumidification kilns and dry bulb and wet bulb temperatures, you can check that out, because they do talk a little bit about reverse case hardening. That is part of the drying process. And absolutely, you can reverse case hardening. It's called conditioning. Case hardening is just an instance of just too hot, too fast. Dan, in your particular instance, if it's 120 degrees in there, that's not really hot enough to cause, I shouldn't say that. There certainly will be species where that will be too hot, but there are a lot of kilns that get quite a bit hotter than that. Also, if you are opening the doors every now and then, like once a day, and just kind of refreshing the air, you're going to reduce that case hardening possibility as well. So, the dehumidification kiln, or the dehumidifier may not have kicked on for quite some time because there's just not that much moisture left. So that's the other thing, is I ask, what is the moisture? Like, what are you shooting for? Are you trying to get it down to 6% moisture? You may not need to go that far. You need to understand what your equilibrium moisture content is. But if the dehumidifier hasn't kicked on in quite some time, there's just really not that much moisture, left in the logs. And as long as you've got continued airflow through there, that moisture should be washed out, out into the outer atmosphere. But I do think opening those doors and letting kind of the air refresh is going to be a good idea. Make sure you go and listen to the episode I did with Timber Woodcrafts. He's running a solar kiln, and he actually talks about how he finds that the solar kiln may not even be possible to case harden because of the nighttime cooling cycle. So I don't know, Dan, whether your kiln is solar powered or if it's a solar kiln. If the heat is being powered by, something by solar power, I think we're talking about a solar kiln, in which case that nighttime cooling cycle is going to prevent the case hardening. You can get the temperature up pretty high, but as long as it's not constantly at that temperature for a long period of time, you don't have to worry too much about case hardening. But since you were just learning this term and are unfamiliar with the whole thing, I highly recommend you take some moisture samples from your boards, cut out some tuning fork samples, and just see how you're doing with the current kiln schedules, the current process that you're following. Which brings up the other point, you really need to have a good idea of what a schedule should be. You don't just set the stuff in the solar kiln and leave it there until you're ready to use it. It does need to dry for a period of time and then come out. You're going to put the wood under a lot of stress if you're continually keeping it in a heated environment. In which case, I highly recommend you go to the Forest Products Laboratory website and download their kiln operator manual. Even if you're not using, a fancy commercial kiln, there's a lot of information in there about drying defects. There's a lot of information about case hardening and reverse case hardening and cell collapse and honeycombing and what causes these things and how to look out for those things when operating your kiln. But there also are several appendices that have actual kiln drying schedules by hardwood species. Now, these are going to be North American domestic species, but you can Google kiln schedules for any variety of species, whatever species it is, and generally you can find some information. So I do recommend that you download this. I will include a link to that PDF in the show notes, but I recommend you build a kiln drying schedule around the wood that you have in your kiln. Now, you may be drying all different species. That's gonna be okay in the lower intensity environment of a solar kiln, but you need to have a baseline. You need to have some idea of how you're doing now. And if you are seeing some case hardening, then you know you need to adjust your schedule and how you don't want 120 degrees of temperature for quite so long. So maybe you need to be opening the doors to the kiln in the middle of the day and letting things cool off for a little bit. It's going to be a little bit of trial error, but it's going to be worth it in the long run. As you said, you've got some beautiful lumber in there. You don't want to ruin it, because once it's case hardened, no, there's no going back. And you definitely don't want to run that stuff over a table saw, because it will throw itself at you across the room. Not a good idea. Now, I talked about the whole tuning fork idea. Just to kind of stress this further, Rob Picaro has been running a blog. Good Lord. I think he even started his blog before I started the Renaissance Woodworker, and he's still posting on it. And he posted an article about some weird wood stresses that he was seeing, and he's got a theory behind. And he reached out to me and said, is my theory nuts or whatever? And I responded in the comments. But it's particularly interesting, and it's worth checking out, because he does actually talk a little bit about that tuning fork idea, but also talks about how sometimes weird things happen, and sometimes there's some odd stresses that can happen with certain species. So I highly advise you go check out this post. If you haven't checked out Rob's blog before, he's an incredible woodworker. It's worth checking out. And you'll see my comments to his question below. It's worth a read. Now, Ben wrote to me and said, is there a standard color coding for the ends of hardwood lumber? If there is, where would I find that kind of information? So if you don't know what he's talking about, you go and look at hardwood lumber stacks, and there will be paint on the ends. Now, we know that paint is there as a drying aid, things like anchor seal, latex paint, any mixture of the two get put onto the end of the boards to slow down the moisture loss and absorption, for that matter, at the end of the boards, where it happens the most, where the end grain is exposed. All those straws, that's where the moisture comes out. As I talked about earlier, standing the board up vertically, the moisture will drain out of there. But if you painted or sealed the ends, the moisture is not going to drain. In fact, it's just going to pool on the bottom of the board, and that's no good either. So key tip, if you're going to stand your boards up vertically, don't seal them, or if they've been sealed, get a nice fresh cut on the end, and then stand the board up vertically. So is there color coding here? No, not as far as I know. There may be something in the softwoods, but what you're seeing there is more of a company code than anything else, because there will be different companies that do different things. Most of the time, like when you go to Home Depot and you may see a bunch of 2x4 lumber that's all painted blue on the end, that's just from a specific supplier. And oftentimes the company stencil, I was going to say brand, it's more of a stencil, is painted onto the end of that stack. So you might find a 2x4 that's got painted blue, and then there's a little part of it that's unpainted. What you're looking at is part of actually the company logo. When you've unstacked those boards, it's like a puzzle. Now you've got to put it back together to actually find that stencil in the end. Certain companies will use certain colors for certain species, or if they're all one species, they will use certain colors for different thicknesses, different grades, also even different widths, but that's just within that particular sawmill, within that particular company. We've got a variety of suppliers that ship us material from overseas. And if I know, that's a stack of lumber from, XYZ company, I can generally go, okay, that's green. That must be, this one's orange over here. This one's blue. These are these species or these different thicknesses. But it's not universal across one company to another. Everybody's using their own particular schema for that. So for the most part, I wouldn't really pay attention to that, other than the fact that if you go to a lumberyard and you see all the same color, you can pretty much guarantee that they bought all of that lumber from the same supplier. So yeah, it is what it is. If anybody knows of a guide to a specific company, I don't even know of one, because really so many different lumber companies are in the business and so much lumber is being shipped in that it just wouldn't make sense to put out a guide to that. I also be willing to bet there's a bunch of companies that really they may not know themselves what happened to be on the shelf. We got to seal that lumber. What do we have today, Vern? Well, it's blue paint today. Okay, blue it is. So yeah, don't put too much stock into that. This is interesting. Tommaso wrote me actually a while ago. Sorry about the delay on this one. But he said, I was watching some random, quote, amazing woodworking tools videos on YouTube. And part of it was in an Asian plant where they were making chairs, starting with what looked like steaming a 4x4 and then compressing them down to 2x4 size. Is this even a thing? Am I not understanding what I saw? So I will post the link to this video in the show notes. It's right about the 25-second mark. But what you're actually looking at is the Hida Furniture Company, HIDA, a very, very cool company. And actually their website is pretty interesting as well, because they talk about like their company softball team and their company ski team and the dormitories. I mean, it actually looks like a pretty cool place to work. But Tommaso, you're absolutely right. They are taking, I don't know the exact size, but we'll just say a 4x4, steaming the crap out of it, and then sticking it in this monster press and compressing it down to a thinner size. And actually, you can do a little bit of digging on their website, but this is called compression technology. Specifically, this is Cedar compression technology. What you need to do this is a relatively low density wood. The lower the density means there's just more air in there, usually either with larger pore structures, wide open pores, like something you would find in red oak, or in softwoods. They don't have pores, but you find that the tracheids themselves are quite large. There's just more dead air and softer fibers in the material. Well, what does that mean? Well, it means with more dead air in there, there's more space to compress the board into. And when we steam the board, anybody who's done any steam venting knows that the lignin and the cellulose and everything becomes more pliable when it's steamed. There's a lot of heat and a lot of moisture injected into the board, and you're allowed to bend it in all kinds of shapes. Well, the same thing happens. As you bend a board around a curve, you're compressing one side, the inside of the curve. You're putting that under compression, collapsing those cell walls, closing up the dead air, all of that extra air in there. On the other side of the band, you're actually stretching it, but that is also pulling out all the dead air. It's just stretching it apart. So imagine taking a rubber band between your two fingers. As you pull your fingers apart, the space between the rubber band gets smaller. Well, if that's a pore, the more you stretch that, eventually that pore goes away, or that dead air goes away. This is the same thing, except now in this press, they're just pushing straight down on it, and they're compressing out all of those all that dead air in the cell walls and in between the cells, and ending up with a much smaller board. And they can actually do a variety of thicknesses, I think all the way down to 18 millimeter. They have some information, some technical documents on the compressing technology, but there's also some proprietary stuff as well. This was actually the guy, I think, who was actually the owner of the company, is the one who first kind of came up with the process. And there are other companies doing it, but if you want your mind blown even further, it's not just a matter of taking a 4x4 and compressing it down to 1 inch thick board. They will also compress into shapes. They can take a board and compress it into a molding profile, or they can just compress it into like a curved chair rail. And there's absolutely no sawdust created here because there's no cutting. So you've taken this kind of rectangular board and pressed it, and out comes a baseboard molding, with a cove in the middle and a round over on the top and maybe even a fillet, because the die, the actual press, is that particular negative of the shape. And as you're compressing that wood, it's just conforming to that particular shape. The same way we would bend wood around a form into a particular curve. They're doing it, and a lot of times when you do bend when you do bend wood around a curve, you often have a negative of the curve to act as the other side of the bend to clamp together and to support the fibers. This is the same thing that's happening when they start with a square blank and out comes a piece of crown molding that's actually just been bent into place. So it's pretty wild. They're manufacturing parts from a square board just by compressing it down. And really where this comes from is cedar, Japanese cedar, Western red cedar. The stuff grows like a weed. And in North America, there is more Western red cedar available today than there ever was. People talk about all the deforestation in the late 19th and early 20th century. Yeah, it was bad, but the Western red has grown back and then some. That's why we have so many wildfire problems, because the and then some part. More Western red cedar available today than there ever has been in the history of the world. And over in Japan, where they have obviously limited land, Japanese cedar has almost become a problem because it grows so fast, and you can't really call it invasive because it's a native tree, but there's just so much of it. But there's been a real problem because there are not a lot of uses for it. It's never really been a good furniture wood in the past because it's just too soft. This stuff, once it's compressed, is fantastic. It's got Janka hardnesses greater than maple. I want to say, oh shoot, now I'm not remembering the numbers, but well, it may be close to maple. I think that's what it was. So it ends up being a very durable wood. And as far as I know, there's no spring back in this. I mean, just like you're going to see a little bit of spring back with a steam bent piece, but like over the course of 10 years is not like it begins to straighten out more. Everything is set in place as that is dried at a particular size. So yeah, this is a real thing, Tommaso. Japanese cedar or cedar compression technology. You can just Google that phrase and you'll find all kinds of technical documentation on it. I know of a few chair makers in North America that are using the same idea, if not necessarily the full compressive nature of taking a thick board and making a small one, but compressing into shapes. There are many companies that make their chair bottoms, like instead of it being a carved out or saddled out chair bottom, it's actually steam bent and compressed into place. So it's bent over form, but then also compressed thinner in certain areas in the middle. There's no cutting whatsoever that's happening there. It's all compression technology, or steam bending, really, in the purest sense of the word. It's all steam bending. You just may not be bending, you just might be flattening. So very, very cool stuff. Good catch on that video, Tommaso. Chris emailed me and said, I just had a forester out to my property for an evaluation of my current agricultural use valuation plan. During the property evaluation, we found many young ash trees, and the forester told me in the northern part of the state of Ohio, there are ash trees that are unaffected by the EAB, the young ash trees, that is, because the bark layer is not deep enough for egg laying. So according to him, the EAB population will decline because they're not infecting other tree species, and the hope is that the young ash trees will be able to mature after the EAB has moved on. So it's an interesting point of view, and I've heard this from a couple of other folks where, especially with infected trees, it often seems kind of a shame where a city will take down a whole bunch of ash trees because they've been infected with the ash borer and just basically turn them into mulch. But the fact of the matter is that the bug itself is just in the sapwood, maybe just really just dipping into the heartwood, but they don't like the heartwood. You know, if you know anything about tree biological function, heartwood is basically the waste dump. So yeah, nobody wants to eat that stuff. They want the sugars and all the life-giving stuff in the sapwood. So they lay their eggs in the bark, and he's absolutely right. The bark layer is just not very thick on a young tree. If you were to cut a sapling in half, you'll see there's just a tiny, tiny layer of bark there. Both the inner and outer cambium layers are compressed into kind of one tiny, tiny little millimeter wide thick range. So there's no place to put the eggs there. And you know, these city municipalities will just grind everything up, and really they're tearing up all that heartwood that is perfectly good because the bug itself is only in the outer sap layers. So I've heard several foresters optimistically say, you know, we're hopeful. We're starting to see a decline already. I'm dubious about whether or not they jump to other species, because I've heard from several other accounts that in the absence of all other food, the ash borer will find something else. But I don't know. Maybe there's a die-off period after that. Maybe they start feeding on oak, and something about oak doesn't agree with them, and they have Montezuma's revenge and die. I don't know. But there is more than one forester that I've spoken to that is a little optimistic that this may die off, or at least die to a non-sustainable level, the EAB population, while the young ash trees are still too young to provide a effective egg-laying substrate. So it's interesting. Anyway, it's kind of a feedback section there, but Chris also has a question. He says, while the forester was there, it was determined that his land management plan requires him to cut out 6 Hophornbeam trees that are overtaking the canopy for a more valued tree species. Is there any good use for ironwood, which is the other name, the more colloquial name for Hophornbeam? Is there any good use for ironwood other than heating the house? The trees are between 6 to 10 inches in diameter. So, yeah, Chris, absolutely. First of all, just broad sweeping statement. There is always a use for a tree. much more. I mean, certainly firewood is one of those uses, but I don't really know of a species of wood that can't be worked into something. If it's too small for any kind of lumber, you make a spoon out of it. I mean, most of the wood that's around there, I've seen all kinds of kind of green wood projects. Spoons just keep coming to mind, but I've seen them carved out of things like azalea. You know, I've got azalea bushes around my house. There's hardly any wood there, but that's what it was. They were carved out of azalea. Rhododendron is another one. I've seen spoons and cups and things carved out of. If it's wood, it can be worked into something. But specifically Hophornbeam, while different than hornbeam, American hornbeam, Hophornbeam is Stria virginiana, and American hornbeam is Carpinus something. Carpinus carolina. Caroliana? Yeah. It's found in the Carolinas. American hornbeam is actually what Lee Nielsen makes their chisel handles out of, by the way. Hophornbeam acts very much the same way as American hornbeam. Hophornbeam is a little bit darker and actually a little bit harder. Hophornbeam is about an 1860 Janka hardness versus 1750 something in American hornbeam. But there's no doubt, because it's a very dense, very hard wood. Yeah, it makes great firewood. It burns really, really hot. But man, there's so many other things. For years and years and years, both the hornbeams have been used for making tool handles because they are so hard and so dense. And I can speak personally for the Lee Nielsen chisels that I've had for more than 10 years that I bang on all the time that look like they're brand new. No dents and certainly no splits. The wood is fantastic for that. So if you were into making tool handles, great. You want to make a wooden plane, even better. There's no reason it couldn't be used for furniture. And you're talking about logs that are 6 to 10 inches in diameter. There's absolutely some usable material in there. So in the interest of the health of your land yacht, absolutely, you need to take those trees down, but absolutely don't just chop them up into firewood. I mean, if you need firewood, certainly you're going to have plenty of stuff in the branches and things like that you can use for firewood, but keep much of that material and build some stuff out of it. Yeah. Just in general, I don't think there's any tree that you can take down and go, it's worth crap. I'm just going to hack it up and burn it all. It's a viable use for wood, certainly, but there's lots of other things that you can come up with. So that brings me, I think, to the end of my show for this time. There's quite a few questions we've hit on. Still plenty more to talk about in the future. But by all means, send me your questions. There, if you go to lumberupdate.com, you'll find a contact form there that you can fill out, or you can record a voice memo like Dan did and email it to lumberupdate@gmail.com, or you can find me on Instagram. I'm there as well as Lumber Update. So look forward to your questions. Look forward to doing another one of these Q&A shows in the future. In the meantime, folks, go buy some lumber.